Hello everyone, I am Dr. Karthika, Assistant Professor, Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this lecture series, we are going to discuss about image enhancement in the frequency domain. Okay. What are the steps in frequency domain filtering? Why do we need image enhancement? Okay, let's go to the topic. First, the steps of filtering in the frequency domain, it includes calculate the DFT of the image. First, if we consider image is F, then we have to calculate the DFT of the image. Previously, we have discussed about the use of Fourier transform and DFT and IDFT. Here, the continuation of a Fourier transform in image processing applications, we have frequency domain filtering applications, and here we are going to discuss about what are the steps of filtering in frequency domain. Okay, the first step is to calculate the DFT of the image F. Second step is to generate the frequency domain filter H. Here H and F should have the same size. H should not be centered, and centered H is for displaying purpose only. And if H is centered, F needs to be centered too, and some post processing is required. And third step is to multiply F by H element by element, and final one is take the real part of IDFT. What is IDFT? IDFT is inverse discrete Fourier transform. Okay. How we construct the frequency domain filters from spatial domain filters? In previous month videos, we have discussed about spatial domain filters, and in this video, we are discussing about frequency domain filters. Okay, how do we construct frequency domain filters from spatial domain filters? Example, here I given an image F and a 9x9 spatial filter as shown on the right. What is the result of this filter? The first one is a spatial filter using the MATLAB command IMFilter, we know that, and we would like to perform the same filtering but in the frequency domain. Here we have our image. We have to perform same filtering but in frequency domain, not in spatial domain, because we are converting frequency domain filters from spatial to frequency domain. Okay, here the frequency domain filters are a very important one, because using this frequency domain filters we can get the highly enhanced images. So we are going to construct frequency domain filters from spatial domain filters. Okay, see here, the first step is zero padding the spatial domain filter H to make the size of the same size, the size of the image F. We have two options. First option is the filter is located at the center of the expanded filter. Here option 2 is the filter is located at the top left corner. Which one is correct? Which is correct? See, the second one. Obtain the frequency domain representation of the expanded spatial domain filter by taking the DFT. Results using the following MATLAB commands are shown below, because in image processing applications we use MATLAB commands for highly enhanced outputs. Here we use the commands IMShow for image show, and we have certain element by element multiplication applications of MATLAB commands. And see here, notice the spectra are the same for H EXP1 expression 1, H expression 2 from shift property, because the differences lies in the phase spectrum. See here, what is H EXP1? What is H EXP2? Here the option 1 is the filter is located at the center of the expanded filter. Which one is? Which is H expression 1. And second, in option 2 we have H expression 2. The filter is located at the top left corner. We have two options. Okay. And see here how 1 and 2 are explained. See here how 1 and 2 are expressed in terms of MATLAB commands. Okay, in step 3 multiply the DFT of the image not centered by the DFT of expanded H. Notice that overall speaking, the high frequency parts of F are attenuated here. See here. In step 4, take the real part of the IDFT of the results of step 3. See the first one, second one, and from spatial domain. Neither one is correct. What's going on? So we have to recall the mathematical expression, a spatial filtering in terms of correlation and convolution, and we have to use spatial filtering as well as convolution theory based on our applications. The origin of spatial filter is at the center of the spatial filtering, while the origin of the filter is convolution theory is at the top left corner. We use both the functions from spatial filtering, functions from convolution theory. Based on our applications, we can use any one of them. See here. Here we have exactly the same results. Actually, the results are from spatial domain to frequency domain are same. Based on the applications, we can use the spatial as well as convolution theory applications to locate the element by element process in specific applications. See. Here, I will give you an assignment for you. Write a MATLAB code to construct an equivalent frequency domain filter for a given spatial domain filter. Here we have an input spatial domain filter H, odd sized, desired filter size, and output is non-centered frequency domain filter H, and plot the centered spectrum. And verify your codes by performing filtering in both spatial as well as in frequency domains and check the results. Take the sum of the absolute difference F, the two resulting filtered images. Thank you.